All right, this is Chapter 8, number 69. Using Table 8.4, estimate the enthalpy for each of the following gas phase reactions. Note that lone pairs and atoms are not shown. So when we do this, we do bonds broken minus bonds formed. And then we made sure to add them all together for both of those, broken and formed, and then that will equal our change in enthalpy for the reaction. And we looked up the bond enthalpies then in Table 8.6. So the ones that are broken are one on the reactant side, and the ones that are formed are on the product side. So the broken ones here in letter A, we have CH bonds, 4 of those, C to H bonds. And then we have a CC double bond, so a carbon-carbon double bond, 1 of those. And then we have OH bonds, 2 of those. And then we have 1 OO bond in there as well, an oxygen-oxygen bond. So those are our bonds that are broken, minus the bonds that are formed. And so the bonds that are formed are over here on the right-hand side. And so we have 2 OH bonds, once again. And then we have CO bonds, 2 of those. We have a CC single bond. And then we have 4 CH bonds right here, CH, 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 and CH. So 4 CH bonds. And if you want to be kind of tricky about this, you can say, hey, there's 4 CHs here, 4 CHs here. Those are going to cancel out. Yep, you're right. And there is a 2 OH bonds right here and 2 H bonds right here. And now you have a few less bonds to look up on the table. And so now we need to go back to Table 8.4 and find those. And the oxygen-oxygen single bond is 146. The carbon-carbon double bond is 614. And then we have 2 times the carbon-oxygen single bond, which is 358. And then we have to look up the, oops, there's a minus sign right here. The carbon-carbon single bond, which is 348. And then we take these, add them together, subtract those that we added together, and we end up with negative 304 kilojoules, and so it's an exothermic type of reaction for that. So bonds broken minus bonds formed. That's letter A. Let's go through letter B. I'll do that one completely, and then I'll just give you the answer for letter C, because you can set that one up as well. Letter B here, we have the same substance where we've got the bonds broken right here. We've got 4 carbon-hydrogen bonds. We've got a carbon-carbon double bond. And then we've got a carbon-hydrogen single bond, 1 of those right here. And then we have 1 carbon-nitrogen triple bond. And then down here, the bonds that are formed would be 1, 2, 3, 4, 5 carbon-hydrogen bonds, a carbon-carbon single bond, 2 of them, right here and right here. And then lastly, we have a carbon triple bond nitrogen. And so canceling these guys out, you can see that the C triple bond ends go away. We actually get rid of 4 of these, so there's actually only 1 CH bond right there. And then we've got to look these guys up right here. Oh, I had another CH bond right here. Look at that. So that CH bond goes with this CH bond. So really I only have to look up a carbon-carbon double bond and then a carbon-carbon single, 2 carbon-carbon single bonds, and then I should be able to find it. So let's go back to Table 8.4 because some people don't know where that's at. So go back here just a little bit. And here is our Table 8.4 of average bond enthalpies. And so we can look up here, a carbon-carbon single bond is 348. And then we're going to subtract from that 2 times a, whoops, that was a carbon-carbon double bond. My bad. Got to go down here for that. That's 614. Minus 2 times the carbon-carbon single bond, which is 348. So 614 minus 2 times the 348, because there's 2 of those right there. And we end up with a negative 82 kilojoules for that one. All right, and then letter C, you'd use the same table right here, same table, but let's go back to the problem. Finally got there. Letter C. And so now we have some different types of bonds, and watch out for this kind right here. Let's just set this one up. Notice how there's a 2 in front of this entire molecule. And so notice how we have a ClN bond, a ClN bond, and a ClN bond. We don't have just 3 of them. We have 2 times 3, or 6 of these NCl bonds inside here. And those are our bonds that are broken, and then minus the bonds that are formed, and the bonds that are formed are an NN triple bond, plus 3 of the chlorine-chlorine bonds right here. So now we need to go back and look up NCl, multiply that by 6, and then subtract from that these 2 species right here. Don't forget to multiply that by 3. And if you do all that, you should end up with negative 467 kilojoules for the enthalpy for that reaction. A nice little exothermic reaction in itself.